Hello students, let us verify converse of isosceles triangle theorem by using Geogebra interface. For this we have studied isosceles triangle theorem. That is, for a triangle if two sides are congruent, then angles opposite to them are also congruent. This is isosceles triangle theorem. We are going to verify here the converse of its. So let us have the statement of the converse of isosceles triangles theorem. The statement is, if two angles of a triangle are congruent, then the sides opposite to them are congruent. Let us illustrate this by using a diagram. Let us have triangle PQR for which the base angles, angle Q and angle R, are given to be congruent. If it is so, is in triangle PQR, angle PQR is congruent to angle PRQ which is given. Then sides opposite to them are also congruent. This side opposite to angle Q is PR and side opposite to angle R is PQ. So these two sides must be congruent. This side PQ is congruent to side PR. So this is converse of isosceles triangle theorem. We are going to verify this by using Geogebra. Let's move to Geogebra interface. This is Geogebra interface. Here we are going to verify the converse of isosceles triangle theorem. For that, first of all, we should draw one triangle whose base angles are congruent. So for that, let us draw firstly a segment with given length. So let us have a segment of length 6 units. We will get segment AB whose length is 6 units. Now we need here two base angles at point A and point B congruent. So we have to draw two angles of equal measures. For that one, we have one icon here, angle with given size. We will click on that. We have to draw angle at point A. That firstly we'll click on point B. So for that, firstly we'll click on point B. Then at point A, then we'll have one box here. Then we'll have one input box here where we have to type the measure of an angle for which we are looking for. Let us draw an angle with measure 60 degree. We'll get this angle. We have to join these 2 points. So for that, click on segment icon, then click on point A and then on point B dash. We'll get here segment AB dash. Again, we have to draw another angle at point B. So to draw angle at point B, so firstly we have to click on point A, then on point B, then we'll get box. We need an angle which is equal to the previous one which we have drawn earlier. So that must be 60 degree. One care should be taken here that now we have to draw a clockwise angle. Just to get here angle 60 degree in this way. Now we have to join these 2 points. For that, again select segment icon, then click on point A dash and then on point B. We get here, as we can see, the measure of angle A, that's 60 degree, and measure of angle B is also 60 degree. That means the base angles of these two triangles are congruent. Now we have constructed one triangle A dash B such that the base angles of that triangle are congruent. That is, both of measure 60 degree. Now, according to the converse of isosceles triangles theorem, we have to verify whether the sides opposite to them are congruent or not. So side opposite to angle B is A dash and side opposite to angle A is A dash B. We'll measure the length of these two segments. So for that we have an icon, a distance or length. Click on that and click on the segment of which the length is to be measured. So click on point A and then point A dash. We get here length of this segment as 6. Again we have to measure the length of segment A dash B. So for that, click on point A dash and then on point B. We get the length of this segment as 6. So as we can observe, the lengths of both of these two segments are 6 units. So by the converse of isosceles triangle theorem, I have stated earlier that if two angles are congruent, then sides opposite to them are also congruent. Two angles of this triangle are congruent, and we have verified here sides opposite to them are also congruent. So this is the verification of converse of isosceles triangles theorem. Hope you understand this concept.